moment of inertia of a thin wire which is arranged in the first quadrant like this in form of a quadri-circle. So instead of having a whole circle of wire, we have 1/4 circle of this thin wire, and we are interested in finding the moment of inertia of this wire which has got a mass m and the radius is r about y dash axis. The mass of this thin wire is m and the radius is r. We are interested in finding the moment of inertia of this thin wire which is arranged in the first quadrant about the y dash axis. So before we get into finding the moment of inertia, we know that is in a circle the length of the arc s is equal to r theta, where theta is necessarily in radian. We know that is for the whole circle this theta is equal to 2 pi radian. So obviously for half the circle it is pi radian, and for 1/4 the circle it is pi by 2 radian. So this length of this arc is, when we say s is equal to r theta, so r into theta is pi by 2, so r into pi by 2, that is the length of this arc. Otherwise you can also say that is the total circumference is 2 pi r, this 1/4 2 pi r by 4, that is pi r by 2 is the length. Because the distance of all the sections of the wire is continuously changing, this distance is continuously changing from the y-axis, so it means we will have to use the concept of integration. For that, what we do is, that is, we shall be using I is equal to dm into r square, and suitably we shall be taking the appropriate limits and we shall be integrating it. So what we do is, that is at angle theta, we take a small section. So as s is equal to r theta, that is over here, that this is d theta angle. So length of this section of small wire is going to be r into d theta, that is s is equal to r into what is theta enclosed, that is d theta is enclosed. So length of this section is going to be r d theta, right? Now what is mass per unit length? Total mass upon total length, that is m upon r into pi by 2. So that comes out 2m upon pi r. Our method remains same. So generally what we have been doing so far is, if we are to use the concept of integration, so at a general distance x, we are taking a small section dx or a small length, and we are finding its dm, that is the differential element of mass. Then we are using moment of inertia, that is dm into r square, and then we are integrating with the suitable lower and upper limits. That is what we have been doing, and that is what we shall be doing here also. So this dm, we have to find this dm, and then we shall be doing dm into r square, that is moment of inertia of this general mass about this axis, that is dm into this distance square. We shall be doing it, and then we should be integrating, that is first section is over here, then this. So theta is going from 0 to pi by 2 radian, then accordingly we will integrate this. So mass upon length, it comes out, the mass is distributed over length, so we shall be talking about mass per unit length. It is not distributed over area, this is distributed over length. So mass per unit length, it comes out with this. Now dm is what? Mass upon length into length, that is length of this. So we get this dm, we get, that is dm is 2m upon pi r into r d theta. Now moment of inertia about this axis is dm into r square. So if this is r, so obviously from here to here is r cos theta, so obviously from here to here that is equal to r cos theta. So moment of inertia of this section about this is dm into r cos theta, this is r cos theta square, that is dm into r square. We are using this formula only, dm into r square. Then what we do is a regular integration. Theta goes from 0 to pi by 2, and then we can solve it. That is, we have done 2m r square pi. This comes out to be r, 2m pi, they are constants. So this is constant, so over here it comes out to be cos square theta d theta. So cos square theta, that is, we know that is cos a plus b is equal to cos a cos b minus sin a sin b. So from here it comes out to be, if a is equal to b or is equal to theta, if a is equal to b is equal to theta, then cos 2 theta, theta plus theta is cos 2 theta, because a is theta, b is theta, so cos 2 theta is cos square theta minus sin square theta. So sin square theta can be written as 1 minus cos square theta, because we know that is cos square theta plus sin square theta is equal to 1 is a basic identity in trigonometry. So from here it comes out to be cos square theta is equal to 1 minus cos 2 theta by 2. So we replace cos 2 theta as 1 minus cos 2 theta by 2. We can do this way also. Anyway, you can do the integration as per your preference. So this comes out to be 1 by 2 d theta, so minus 1 by 2 cos 2 theta. Integral is sin 2 theta by 2, and limits we take, and finally it comes out to be mr square by 2. So moment of inertia of this thin wire, which is in this quadrant, first quadrant, mass m, radius r, about the y dash axis or about x dash axis. This is always symmetrical, about this also symmetrical, about this is also symmetrical. So it is going to be mr square by 2.